Good morning, good afternoon, good evening, everyone.
Hi.
Hello.
Hi, good morning.
Good evening.
How is everyone?
All good, Kendall?
Great. I don't know about y'all, but I'm ready for the weekend.
It's all good. Everybody likes it. Almost there.
Almost there, almost. Right, we'll give it just another minute. People are still logging on. All right, we do seem to have a pretty packed agenda, so let's just go ahead and get started. I know people are still logging on, but just in the interest of time, we only have an hour, so let's go ahead and get started. So first thing on the agenda is a domain proxy update from Arthur.
Hello, can you hear me?
Yes, I can.
Okay, I'm gonna start the camera now. Please tell me if you can see me.
Yep.
Okay, so today I would like to present to you guys a short demo of the domain proxy development we've been doing for some time now with FreedomFi. So my name is Arthur. I also have or should have Joey with me. Maybe there'll be some questions, although I don't intend to add a Q&A session. I'd prefer to handle any more technical questions on our dedicated Slack channel, but yeah, so that's what we're gonna show. I'm gonna jump to my presentation view. So the agenda for this demo is as follows. So first of all, a very brief general information about domain proxy, where to find us, where's the code, where's the Slack channel. Then I'm gonna move also very briefly about the domain proxy architecture. I'm not gonna dive very deep into it, just more like a high level view of what sort of services and components we have in the application and how does this domain proxy application lie in the orchestrator environment. Next, we have the main focus of this demonstration, which is the Happy Path demo. And I intend to show you how to add ENB, a Cpsd ENB to the Magma's domain proxy, which will then hopefully get registered with a Spectrum access system, get some frequency grant for it, and turn on the transmission. And on the last mention on the agenda, I have some basic troubleshooting. I'm going to show you the link to the documentation we have in Magma, and I'm going to show also briefly how does the different layers of communication work and how you can possibly debug it on a very basic general level. So for general information, so we have a Magma Slack, you should all know this, and there is a Slack channel dedicated to the domain proxy. I posted the link here. I'm guessing this presentation will be also made available to you, so you can click it here or you can find it in the list of channels in the Magma Slack. The repository is obviously Magma. Magma, we are more interested in the DP module, which is part of the now Magma repository tree. And for our daily activities, we are using ZenHub taskboard, which also there's a link here. We run our project in 3-week sprints with daily internal calls and 3 times a week stand-up, which is open on Fridays to the community. And I believe this is also visible on the Magma calendar as well. I encourage anybody who's interested in domain proxy development and more up-to-date status, a little bit more technical, that's the place to go. So on Fridays. Now, briefly about the architecture. So there is a documentation also on Magma. I posted a direct link to the Markdown document from the master branch, which should be the most up to date. But the more in a high level view, what this demo will show is that we're gonna access the Nms Ui, and through that UI, we're gonna fire some operations, some actions on the Cpsds, which in turn will cause Obsidian REST API to be called, which will then call our domain proxy orchestrator service, which will do some operations on the orchestrator database. And that database serves as a source of information for the domain proxy application to work its magic. So that's the path that we can show. And on here, we're gonna also observe a little bit of different paths, so more from the perspective of the ENB, which more or less looks like this. So we have an ENB device hooked up to an access gateway. Now this ENB is being configured through TR069 protocol, which is talking to a service on the access gateway called enodebd. And the flow will, which will show is that enodebd will continuously query domain proxy for the Spectrum access systems grant data, which are the frequencies for the transmission. And hopefully the radio will eventually get this information from the domain proxy here and set the correct parameters on the device itself and enable the antennas. I will also briefly talk about the flow, what's happening exactly on the domain proxy application side, but looking at the very high level, we have three major components. The radio controller component is like an entry point for our like entry interface for the access gateways, and also serves as an entry point for a different microservice we have, which is called here an active mode controller. So this guy here implements like business logic. It knows what to do when a specific state is retained in the database, how to manage the states, how to transition, how to generate specific messages. And the last component we have is what we are calling it a configuration controller. So this component is mainly responsible for management of the Cpsd to SAS protocol with the Spectrum access system. So this is a more like a protocol controller, which knows how to talk to SAS and how to interpret the responses. And let's jump to the demo. So first of all, I'm going to show you the Nms UI. You should all be more or less familiar with it. So we're going to look at the equipment tab. You'll see the various access gateways here. So we have one for the purposes of the demo. So this is the access gateway that we'll be using. In here, you can see that we have two ENVs added to this access gateway, but the one we are interested in is this one. And this is a Sercom ENV, a Freedom 5.1 model. So this part of the configuration is already present in Magma. Now, what I'm about to show is the additions that we are working on. This is not yet in the Magma repo, but it will soon be. So these are the extensions for the NMS to support management of the domain proxy resources. In the equipment tab, you'll see an extra tab, which is called Cpsds, and this will allow us to add or modify or delete the Cpsd and Bs managed by the domain proxy, which I'll show you in a second. And then another extension, which we'll also show during the demo, is the metrics tab and precisely the domain proxy logs, which will show you communications between access gateway and domain proxy, both ways, and domain proxy to the Spectrum access system, also both ways. So let's start with adding a Cpsd. So we have the Cpsd tab open in the NMS, and I'm gonna add the ENB that you already saw in the previous equipment tab added to our access gateway. So let me bring in the bringing the form to add the Cpsd. So some of the fields here are blacked out. I hope I did it correctly. So we have some sensitive information here that I shouldn't be allowed to show, but I'm going to use this form now to add this ENB so that it's now known to the domain proxy. So we have the serial number here. We have the FCC ID. We then have a field called user ID. So those are parameters required to, you have to put them in because they're a part of the communication between the Spectrum access system. Now we have some other parameters here. This is partially blurred out, but this is a min and max power of this device. So I'm just going to put in the data I know that's relevant to this particular device. So we have max power 24. It has one antenna, no gain. And here we have a selection of preferences of what should this device, which sort of frequency bandwidth or the frequency range is the preferred one that we should be using. So this requires a little bit of knowledge of the CBRS, but basically whenever a device is talking to the Spectrum access system, it asks for all the available spectrum frequencies, and there could be many of them. So here we can select our preferences. So from among all the available ones, we can select a preferred one. So here I'm also going to say that we have a 20 megahertz bandwidth, and the frequency should be around 3.6 gigahertz. All right, so I've added the Cpsd in. Now on the other tab, I'm going to show you the logs section live while this is happening. And on this screen, what you can see is that we can see this is live, so we can see that there is a flow of communication happening. Before I did this, there's a flow of communication happening that originates from the Cpsd to the domain proxy, and domain proxy replies to the Cpsd. It's technically, it replies to the access gateway's inode service, but it is intended for a particular radio. Now, this flow here demonstrates that the INB connected to the access gateway is continuously probing in a set interval for the most active configuration. Now, with each of this cycle, there is an additional step in the INOD's implementation that we added, which does this communication that this particular radio asks for a grant data. And all those communications that you see here is that the Cpsd requests for some state, what's the state of this ENB in the domain proxy, but the reply is empty, meaning we don't have yet a grant for it. We haven't acquired it from the Spectrum access system yet. Now, this table is being updated live. The payload is blacked out because it also has some sensitive information, but you can see that the radio is continuously probing the domain proxy, but from time to time, we can see that domain proxy is issuing some commands towards the Spectrum access system. So right now we are at the heartbeat stage. So this also, maybe I'll not dive that deep into this part in particular, because this is a Cpsd SAS protocol. So whenever a radio talks with a Spectrum access system, the SAS has a very state-driven basic call flow, which you need to conform to. So first of all, the device needs to introduce itself using a registration request. then it has to request for available spectrums for it, then pick one from this spectrum and tell SAS that it's going to use it, and SAS then replies, well, eventually it will reply that, yeah, you're allowed to use it. So this is all domain proxy working in the background. We can look at the communication flow here in this tab. Now, unfortunately, for you don't see the payload here, but right now the SAS gave us a grant, but oh no, now it did. Okay, so I'm sorry you didn't see this, but we saw in this call flow information from SAS that it was still calculating interference for the check for the grant that we requested. Now, in this exact moment, SAS replied that it finally gave us the permission to use the selected frequency. So the frequency here is starting from 3.59 gigahertz to 3.61 with max ERP value of 10. I'm going to jump back to the Cpsd information. Now I need to refresh this page in order for this information to be reloaded again. We don't have yet an auto refresh, but I'm going to use the magic of the browser, and in a second we're going to see that yep, this device is now registered at SAS. It has an active status. This is the serial number that we were interested in. All the parameters are being set, and we see that this grant that we were given by SAS is due to expire on somewhere at the end of May. And at this moment, all this frequency information has been passed from the domain proxy to the access gateway. In turn, access gateways inodebd configured the Cpsd with the parameters, and I can also go back to the logs page. Sorry, but this is blurred out. But as before, we could see that Cpsd was asking for its state and the reply was empty. Now it's constantly receiving a payload. Now this payload I can actually show, but it's the exact same data, which is the frequencies and the max power that the SAS granted for this particular device. And as a last step, what I'm going to do, I'm going to go back to the Cpsd screen right here, and I'm going to remove this device from the domain proxy. Now, what will that do is that will tell the domain proxy that this device is no longer part of the environment, so it should be accordingly removed, or as we call it, deregistered with the Spectrum access system, and relinquish the acquired previously grant. So that's what I will show you right now. So let me go back to this tab, and here I can remove this device. Are we sure? Yes, we are. And quickly in the logs page, in a short second, we shall see that this device is being removed from SAS using a specific call to SAS called the deregister, and the Cpsd will stop getting the, here it is. So at around 5:18 my time, the state request stopped getting any grant data, and we can see at the very top that domain proxy issued at the registration request towards SAS. SAS replied correctly, said, yep, everything is fine, and relinquished the grant. Okay. Now, basic troubleshooting. What can you do when something goes wrong? So there are 3 layers of communication happening here. first of all, there could be some problems between the ENB and the access gateway. So the only way to view it in a more detail is to log in to said access gateway and look what's happening in the logs. So how are we standing with time? Okay, we have 10 minutes. So yeah, let's quickly then jump in here. So you can view those logs using the, for example, the tail command. And there's nothing wrong right now because this is a happy path demo, but in here you'll see that there's a flow of logs. There's a lot of debug logs, but if there is something wrong with the ACS, you just look it here and see what are the problems. And in particular, which I'll show you in the presentation in a second, the intended flow of the logs, if everything is right, you should see a sections of this log message where the device first contacts access gateway using TR69 inform message. You will see a similar log like this, that ACS received an inform message. It then tries to fetch all the parameters from this device. They are specific to from model to model, and these are detailed in the drivers of eNodeBD. But on the one of the last stages, after all the parameters have been fetched, this is what you're looking for. So somewhere around ending the session, the first session of TR69, you will see that ACS is transitioning to a state we call notify DP, notify domain proxy. And this is the moment where the communication from the access gateway to domain proxy happens. So at that point, access gateway is sending the request towards domain proxy, trying to get the frequency parameters obtained from the Spectrum access system. Now we can see here that it got some reply, and it's basically updating the desired configuration of this particular ENB, and this configuration will be applied during the next periodic inform session, which I just showed. So that's the only way you can debug it there. But from the perspective of the ENB, this is pretty straightforward. The flow is untouched. It's just one additional step, which either gets some data from domain proxy or it doesn't. If it gets the data, it sets the parameters and enables the transmission. And if it doesn't get a positive response, it just disables the transmission. So from this point of view, it's fairly simple. The second line of communication is between the access gateways eNodeBD to the domain proxy. So this is exactly what I just said about this state. At this point, the eNodeBD calls a gRPC API in the orchestrator service. And this is gRPC, so I won't show you anything that's readable through a capture or in the logs, but if you do a journal logging of the control proxy service running in the access gateway, if everything is okay, you should see logs similar to this, that there is a call being done to the domain proxy service in the orchestrator, where the API gRPC function is called get Cpsd state. And yep, that's what you can do on the access gateway. Now, and the other one is what I showed during the demo. You can use the NMS and get to the metrics menu and then select DP logs. And here you should be able to see all the requests and responses with the parameters. So I took this screenshot earlier this morning my time. And that's basically how it looks like when it's not blurred out. So you see that there are communications from Cpsd to the domain proxy and domain proxy to the Cpsd, and there are some parameters here with the dates. You can check it here. The last line of communication is between domain proxy and SAS, and in here you basically have two ways. What you can do You can also access the domain proxy logs, but either filter, or if you'll be lucky, you'll just get it what I got right here, which is a very brief snippet of communication between domain proxy and SAS, and then what SAS replies. And earlier today, when I did this run, you can see that there is a heartbeat request being sent by domain proxy to SAS, and SAS told us that well, there is some pending operations still on the SAS side, so the grant is the error code here 501 means that the grant is suspended. It is being assigned to our ENB, but we are not yet allowed to enable transmission. But this is the first line which you can use. The second line which you can use to troubleshoot is to access the services themselves in the orchestrator. I also posted a link to the documentation. So what you use is most generic Kubernetes tools for the deployment in the Kubernetes on the AWS, which we have here. So you can list the domain proxy pods and get the logs using kubectl logs. Now these are very specific, but these are application logs. So if you suspect that there is some problem between domain proxy and SAS server, then you are most likely interested in the configuration controller logs. And if you suspect that there is something wrong with receiving the gRPC calls from the access gateway, you are then most likely interested in the radio controller logs. And lastly, if you suspect that the flow is, so there's something wrong with the business, with the logic or the management of the states, that's probably active mode controller's fault, and you can also get the logs from there. And that's the last slide, guys. So this was a first introduction to a wider audience of domain proxy. I imagine that it could be a lot. Please, if there are any questions, please, I'm going to just show you this slide, the first slide, just in case. Use the Slack channel, try to contact us. If some of you will try to use it, fire any questions there. We try our best to just reply. And as for the features presented in this demo, I imagine they should arrive in as a PR within a week. Because we are more or less ready to introduce the first version of the NMS extension towards domain proxy. Okay, and that's it from me. Thank you so much for listening.
Thank you. Are there any questions?
I have a question here, if there's some time.
Yep, go for it.
Awesome. I'm curious about what's intent in terms of those components being deployed. Are they going to be deployed on each orchestrator deployment? And here, yeah, I'm speaking specifically about orchestrator, or is it, or do you have to, or is it just going to be like an add-on that you can have if you want to use CBRS for your orchestrator deployments? Because most deployments are not using CBRS as far as I know. So I'm curious about that.
Yes, that's true. So domain proxy as a module can be enabled or disabled using Helm. And this is specific towards the deployment. If I remember correctly, domain proxy right now from the master, the domain proxy feature is disabled by default, so that it doesn't interfere with all the usual deployments. And if you want to deploy the domain proxy along with your orchestrator, you have to tune in your Helm charts to enable it. If
okay.
that's
yeah, that's pretty clear.
Mm-hmm.
And another question on this same topic is like for most other types of add-on, let's say for like LTE, like the service name is called like orchestrator LTE or orchestrator SMSD or whatever. Should we do something similar for CBRS? Because that's really specific to CBRS, right? Because domain proxy seems as a very generic name for something CBRS specific?
Well, it's the way I can answer it is that domain proxy is this is a term for an application that resides somewhere between the CBRS device and the Spectrum access system. It's just called a domain proxy, and not all the devices actually have. In the demo I showed the Sercom, which I think has a built-in SAS client, but we can utilize Access Gateways eNodeBD to support a multitude of devices, and the domain proxy implementation we have in Magma is actually a vendor agnostic. It's neutral to the device, because the specifics of configuration of the device is embedded in the specific device driver in the eNodeBD on the Access Gateway. But the whole idea of domain proxy, this is CBRS domain, this is CBRS specific.
I also want to jump in because
Go ahead,
the
John.
name, the name domain proxy comes from the FCC, the WIN forum. It's what it's called. If you call it some other name, then Magma is creating its own name for a CBRS domain proxy. So we just stuck with the original name.
Okay, understood. Thank you.
Okay, thank you guys. All right, for our next agenda item, Basel coverage from Lars.
Yes,
Yeah.
hi.
Sorry, Lars. Okay.
Sorry.
I was just gonna introduce Lars and Christian, since they're also with TNG, and we are going to again today talk about Basel a bit and give you some short demos about this time Basel coverage and the Basel query language, which Christian will do later, and Lars will now start with the Basel coverage stuff. For those of you who haven't been here last time, we're from TNG, and we work on Magma for about half a year now. And mainly one direction is the Basel direction that we work a lot in. And Lars and Christian are kind of some of our experts there, and they'll show you some demos of what we have been doing so far. So yeah, Lars, feel free.
Sorry, I just got kicked off. Alex, are you done with Go or?
Yeah, and then you can, sorry.
Okay, sorry. Okay, so I'll just go on my screen. Yes, so I'm Lars, and yeah, we want to showcase some more Basel functionalities, and maybe you've heard of the ongoing Baselification efforts. So we are trying to migrate the build system from Make and CMake to Basel. And Basel has many benefits, including caching during the builds, etc. But today we want to showcase the coverage verb. And yeah, so what we want to do here is we want to generate unit test coverage for any targets that we want. So here I'm just in the dev container. This is just a branch on the current master. And we can just take Basel and specify the verb coverage. And here I declared 3 groups of targets. So these are all the Python targets in the LTE and orchestrator folders, and all the C targets in the LTE folder. And these dots get expanded to all the test targets that are found in these folders and subfolders. Yeah, so this is also nice. We can do this coverage and testing for all different kinds of languages. So this includes C, C++, and Python here, but for Go, it's the same. And perhaps I should also mention that this coverage that we're generating with Basel here is not part of the CI as it is. So this is just as a demonstration, also because we haven't fully Baselified Magma yet. So we can just run this, and this will build and test everything and generate coverage. since I've already ran this and Bazel is really good with caching, this is very quick. So you can see that these results are now cached. We see that 153 tests were considered in these targets, and they all passed. Although we can see that there are two tests here in these C folders, MME app procedures, and the Cloud Reporter test that were marked as flaky, and they failed in some of the runs, but they did run at least once successfully. And now this already generated the coverage data, but it's not really sort of human-friendly format. And we can use a different tool, which is called GenHTML. And we can specify an output folder and specify the data that we want to look at. And this will generate an HTML page from this coverage data. So if we do that, we already get a quick feedback from the overall results, but we'll see the same in the HTML. So we can go to the host system, and we can just use Firefox or some browser to open this index file, which is in the folder that we specified. And if we do that, we get the coverage report here. So here we get the overall result in terms of lines and functions. Although we have to be a bit careful about these function numbers here, because for the Python services, functions are not recognized as such. They're just treated as lines. But for C and C++, the functions are sort of understood. And yeah, we can look at some examples here. For example, we can go into this folder here, which is C, and the service registry. Overall, it says that 66.3% coverage in terms of the lines, and it also recognized some functions that were covered here. So if we click on that, we see that there's only one single C++ file. And again, we see the coverage for that. And clicking on that, we can see the individual lines that were covered. So we see that some functions here were not used in red. The blue was covered. The coloring is not always perfect with what is generated here. So for example, this line is white, but it was covered because it's part of the line above, sort of. And we also see that some conditional statement like this else statement here were not accessed. And if we go back, we can also, so here we see all the different folders and services. And we can also look at some Python service here, for example, pipeline D. And we see that the coverage is quite low. And this is part of the fact that this only includes unit tests. So we're not covering integration tests here, and we're also not covering pseudo unit tests. And for example, pipeline D relies heavily on the pseudo unit tests. So the coverage here is displayed lower than it actually is. And here again, we can click on some Python file, and we can also see which lines were covered and which ones were not covered by that unit tests that we did run. Yes, I think that is it so far from me. Are there any questions?
Let's jump to the next topic.
Okay.
Okay. Hi, my name is Christian, and I am from TNG, and I will talk about the Bazel query language. So Bazel is an artifact-based build system. This means that it's more declarative, and we can specify a list of artifacts to build and their dependencies and a limited set of options on how to build them. This makes it more granular, and which helps with the caching and also with the incremental builds. And we have a lot of build targets, and Bazel provides the Bazel query language to query these targets. And I want to show a few examples why this could be useful for you. My first example is about the pseudo test. So this query consists of two functions nested into each other. So first we find all of the Python tests inside the LTE gateway Python directory. And we only want those Python tests that have the tag pseudo test. And if I execute it, we can see it will find all these different test targets. Most of them are in pipeline, the mobility, and this can be useful to, it's useful to have a list about the pseudo tests because they are kind of between unit test and integration tests, and it's even better to have a command that can generate this list for us. And a similar example is we can, for example, query the Pi binaries in LTE gateway Python, where the main attribute is main.py. So with this, we will get all the basalified Python services, their main entry points, the main targets for it. And this can be useful, for example, in a shell script for CI if we want to execute all the Bazel services with Bazel. And one of the most important features are that we can query the dependencies of a given target. So here we will get the dependencies for monitor D. If I execute this, we will get a lot of lines. These are mostly external dependencies which are prefixed with this @ and so this is not that usable in this form, but we can apply some filters to it. So for example, we can, with some regex expressions, we can remove the ones which are external with this @ symbol, or they have external in them. And if I execute this, this is much better, much more relevant. And these are the dependencies inside Magma. So this could be further filtered to have a much better output. Like there are some things that are repeated, but for the point of this demo, this will be enough, because I want to show you that if you add this output graph option, you can generate a dot-based graph. And if you copy the output from this command, and then you paste it inside any dot-based graph visualization tool, and then you will have a nice dependency graph here for monitor D, and this could be very useful for a lot of different stuff. Are there any questions? If there are no questions, then we can go to the next topic.
Okay. The next topic is a current PR that we have open. It's about upgrading Go to a newer version that is Go 1.18, which was recently released. Our concrete motivation is that it is needed to implement distributed tracing, which there's a proposal to implement this, and yeah, which we would like to work on, which needs open telemetry modules which rely on higher Go versions, but also the current Go version that is predominant in Magma 1.13 isn't supported since about, I think, 1.5 to 2 years. Yeah, so an upgrade might be in place or might be necessary there as well. What is 1.18? It comes with a couple of new features as well that might be useful in the future. For example, it's the first release in Go that supports generics, and it also comes with a workspace mode that could be helpful for Magma because it addresses difficulties in repos that come with multiple modules, as Magma does. Yeah, the PR itself is not merged. It's still in review. But it's quite big. Don't be don't intimidated by that. Most of the files we touched are generated changes. That is due to version bumps in Go Swagger and protobuf modules. And that kind of makes the PR very, very large. But yeah, we hope to get it merged soon. If you have any questions or if you want to, I don't know what want to review it, maybe. For example, we still need reviews by domain proxy as well. Sorry, Arthur, maybe. But yeah, if you have questions, just feel free to talk to us and contact us. And yeah, hope to see this happening in Magma soon. Thanks.
For the record, domain proxy is aware. We just didn't have time to test. Yeah, we just didn't have time to test it because we basically would like to get this pulled to our most active development branch and redeploy it with it just to make sure. I mean, CI does some of the work, but not everything. So we are aware of it.
Great, thanks. Yeah, and if you have any questions, just contact us. Thank you.
Mm-hmm.
Great. Are there any questions? If not, we'll go ahead and move to the next topic, which is a 5G update. Would that be from you, Daljit?
Yes, kind of. I'll share my screen and start on this. Okay, so the Wavelabs team is working on 5G assay release which is going to be on top of 1.7. It's 1.7.1 at this stage. I divide the feature into various categories here. There are features which are already tested. They're ready for release in the first block there. So key extension, stateless feature, and the splitting the external service, internal services. And the next set, the feature which is in development is programmable GTP extensions, which the development is still in progress. And then we have another 3 features which are under testing, scale and regular testing. And this is 5G QoS and the dual IPv4, IPv6 port and network initiated session modification. And at the same time, parallel, we are ready to start on the release planning. The scale testing is continuing. Plus, we are working on this scale testing using A-board, Spire, and test cases for these all extended 5G features. And we will talk in the one of the slide, plan for overall release for 1.7.1. This is the hardening for the regression testing. Continually, we are working on this, and there are some features, some issues we have fixed and have issues fixed. The couple of them related to scale test retry request. This is kind of blocking the clean test for the scale test, where there we see the duplicate retransmission of request either for the registration or the PDU session. So those were cleaned up, fixed. And then were some fixes related to debugging and cleanup. One was related to this NMS dashboard showing the wrong values for the data uses. That's got fixed. And there's some issue related to debugging of the QoS. And then the one peer merge related to SCTP shutdown for NGAP protocol there. This is the 1.7 feature which we are either in development or testing. So we have with the 5G QoS, we still have like a 3 peers in different stage of reviews and working on this. IPv6, we are just continuing the testing with one of the issue we fixed. So a similar thing with network initiator session modification. We have 3 PRs in various stages. We are working on those. GTP extensions, we have 2 components there, OVS and RVU enhancement. We have a series of PRs which are under review there. And with our regression testing, we are finding any issues and fixing them. And there is 1 PR for pending for merge here in the regression and scale test. This is just sort of like, start putting the high level view of how the release, how we are going to work on this release, right? We have these lot of, there are around 14 PRs which got merged to the main trunk. We are trying to move, we have to trying to move to 1.7 branch so that we can work on 1.7.1 release. And we are changing them and trying to get those merged. And then we are also working on our plan for CI/CD health check we are going to work with the community, and we will have some meetings on this. And the next set is release management. So that's something we have started the discussion. We are going to see how we can, which branch to use and how to freeze the code, and continue working on the regression testing. Where all other general documentation we do for the release, right? So CI/CD is one of the big one we will be discussing in coming days, and also in parallel we are continuing testing with the real comments, and we will have reports and benchmarking numbers for the scale and performance. This is generic 5G test status report. So this is our plan for 1.7.1 using YSL node V testing and Huawei. We will UEs, we will do that testing. And then I think one of the important part is Rubaka A-bot testing we are doing with CI/CD. This is something we will have discussions in coming days. Is in good state, or anything else need to be done. And generic scale testing 200 UEs we are working, and also parallel we are working on 400 UE testing and way beyond that. This is very much we have 5GSA status. I think overall this is preparing for 1.7.1 release. Any questions? All right, Kendall, back to you.
Thank you, Daljit. For our last topic on the agenda, we have a DevOps update from Shubham.
Yeah, hello. So from DevOps side, first thing we have removed TerraVM and Spire and Test from our CI dashboard. We will be stopping the support for these. We have also removed it from our GitHub Action CI pipeline. Another thing, like we were trying to do SRSRAN test with ARM-based access gateway, and now that is successfully done. Now we are like documenting it and building like deployment scripts. It will be out soon. Another thing, for same thing, we are also building CI pipelines for testing access gateways with like SRSRAN and open simulators. So we are currently benchmarking with 2 different platforms. One is Firebase and second is EC2 instance. We are doing speed tests and benchmarking in all other ways how we can do this. And last is that we currently, our Artifactory is deployed on a bare metal in France. And we are in talks with Open Infra team that they will provide us some cloud-based Artifactory managed by JFrog. So we will soon migrate everything from our current existing Artifactory to there. So basically domain's name domain and everything will remain the same, but yeah, this process will happen. So we may face some downtime. Yeah, so we'll update on this. Any questions? Okay, thank you.
Okay. Thank you. Are there any other business that people would like to bring up that is actually the end of our planned agenda? If not, then we can go ahead and end 5 minutes early. Thank you, everyone.
Thank you. Bye-bye.
Thank you.
Thank you.
Have a good day.
Thanks. Bye.
Bye.
Bye.